So this is going to be the distance vector algorithm. And I know from experience that when I look at the videos that I make for SI, that people watch like a few minutes of it. But on this one, don't forget to stick with it, or at least jump to the end, because at the end I'm going to talk about some words that go along with this, that you'll want to make sure that you know, just in case it comes up, that talk about, I'm going to write these down so I don't forget, that it's iterative, asynchronous, and distributed. So I'm going to talk about each of those things. And then also, I'll go ahead and talk about this now, that the cost that we're coming up with for each of our nodes comes from the Bellman-Ford equation. Which is that the distance from node X to node Y at each step, at each iteration, is going to be the minimum value taken over all of the directly attached neighbors. So V is a set of directly attached neighbors. And I'm going to explain all this. Directly attached neighbors. So the minimum taken over all of the directly attached neighbors of the, I don't know why I wrote it down there. Minimum taken over all the directly attached neighbors of the cost or distance from X to V, where V is one of the directly attached neighbors, plus the distance from that V to Y. Okay, and we'll see how that works. All right, so this is the problem from last year that he put in the old homework section. So we have 4 nodes, W, X, Y, Z, and on our first step is easy. You just take for a given node, like I'll just do them in order, alphabetical, so I'll do W, so this will be W, and then X, and then Y, and then Z. So for the first step, all you know about are your directly attached neighbors. And if you're not a directly attached neighbor, you are never going to fill in that row on your table. So for example, for W, its only directly attached neighbors are X and Y. And so W is never going to have a row on its table for Z, because W only talks to its directly attached neighbors. So we know no matter how many times we have to iterate, and I have this up for 3 just because the solutions have 3, so we'll see. I assume that's all we need. But no matter how far out you have to go, there's never going to be a row for Z on here. So this is first iteration, and the second column will be second iteration, and the third column will be third iteration. So for the first iteration, if you are node W, all you know about are the things you are directly attached to, and you know it costs you 0 to get to yourself, and you know it costs you 10 to get to X, and it costs you 9 to get to Y. You're not attached to Z, so you don't know about that, and X and Y have not given you any information yet, so you don't know about them. Even though they're directly attached to you, what this row is, what row X is what X has told you about how much it costs for X to go to W, X, Y, and Z. So if I'm in W's table, each row is the information you got from that node. So that node sends you its distance vector. So what I just wrote is W's distance vector. So the rows x, y, and z, those will be the distance vectors that x, y, and z send to W if they send them anything. Okay, so now we go on to x. X is directly attached to W, Y, and Z, so it will eventually have rows for all of those. Its cost to W is 10. Okay, so but right now, it hasn't heard from anybody else. So for right now, on the first iteration, the other rows are all blank because it hasn't heard from them. So x's cost to W is 10, x's cost to itself is 0, x's cost to y is 4, and x's cost to z is 8. Alright, now we'll look at y. Like x, y is attached to everybody, so y will eventually have a distance vector for every node. But right now it hasn't heard from anybody yet. And its cost to W is 9. Its cost to X is 4. Its cost to itself is 0. And its cost to Z is 3. Oh, and hold on. I just put another little copy of this in here so I could see it from Z. Okay, I might be able to do this from by typing. That'll be neater. Okay, so Z Z will never have a row for X because Z is not directly, no, Z will never have a row for W because Z is not directly attached to W. And so Z will never have a row for W, so I'll go ahead and just fill this in across. Oh, I should probably write, this is too slow. Okay, so Z is only directly connected to X and Y, so Z will only ever get information from X and Y. So that's one of the things about this algorithm is that you only are getting information from your direct neighbors, so you don't have to be getting information from everybody in the entire network. You're only getting information from your direct neighbors, so that is going to save time and traffic and everything. We're on Z. Okay, so Z right now has no idea how to get to W because it's not directly attached. It costs 8 to get to X, it costs 3 to get to Y, and 0 to get to itself. Okay, so now what happens is each node now sends its own vector to its directly attached neighbors. So W is directly attached to X and Y. So W is going to send its distance vector, which is 0, 10, 9 dash. It's going to send that to X and Y. So we'll fill that in on W for X and Y. Okay, so, and we know it's not ever going to send anything to Z because it's not directly attached. Now X is going to send its distance vector to its directly attached neighbors. It's directly attached to everybody, so it will send 10, 0, 4, 8 to everybody, except for itself. It's going to calculate its own new values for itself using the Bellman-Ford equation. So let's send this up here. So X 10, 0, 4, 8. Alright, now Y is directly attached to everybody, so it will send its vector to everybody, 9403. Not itself, because it's going to calculate that for itself. And now Z. So Z is directly attached to X and to Y, so it'll send its distance vector to X and to Y. So that's dash 830. but not to itself. Okay, all right, so now we're going to calculate the next distance vector. So for w to itself, that's never going to get smaller than 0, so we can just go ahead and fill that in. Now for w to get to x, all right, so for w to get to x, right now it's 10. Now it's going to look at the other vectors that it has and to see what are the costs for the other vectors to get to x. Well, for x to get to x, it's 0, but that doesn't do you any good because it already costs you 10 to get to x, because you're going to have the distance that it costs you to get to that node plus the distance for that node to x. So, for instance, on this one, it's easy enough to see because we can look at the original graph. So on our original graph, we can say for w to get to x, it could go straight to x, and that would be 10. So we already have that one. And then it doesn't really make much sense to look at the x vector, because to get directly to x, we already know it's 10. It's 10, but then plus 0 for x to get to itself. So that one doesn't help us. But let's look at y. Let's see, so right now we're trying to figure out what the minimum of our directly attached neighbors are. So it has 2 directly attached neighbors, and so from x, it would cost 10. Now, to get to x going through y, we look at how much does it cost to go from y to x. To go from y to x, it costs 4. So we'd have 4 plus how much did it cost us to get to y in the first place? That's right here, that's 9. So that'd be 13. So we take the minimum of these two, which is 10. Okay, now we'll look at node y. So it currently is costing us 9 to go directly to y. And then again, if we just look at node y, that doesn't really help us because that's going to be exactly 9. How much would it cost us to get to y going through x? Well, to get to y going through x, it would cost us from x, it costs 4 to get to y. And then it already takes us 9 to get to y to start off with, so that would be 13. And so our choices were, takes us 9 just to go straight to y, so that's our first choice. Our second choice was to get to y through x. It would be, I guess that's 14, sorry. To get to y by going, let me do that again. Let me see what I did wrong. To get to y by going through, I see what I did wrong. To get to y by going through x, I look and I see what is the cost to go from x to y. The cost to go from x to y is 4. Plus, I need to get the cost to go to x, which was 10. So the cost that it would take to get to y going through x would be 14. So I can either choose 9 or 14. I'll choose the minimum, which is 9. Okay, so my w distance vector didn't change. Let's look at my x distance vector. All right, so to go from x to w, so I'm starting at x, and then I'm going to look at the cost from each of x's direct neighbors to get to w, plus the cost to get from x to that neighbor. So x's direct neighbors are y, are w, y, z. Those are x's direct neighbors. And we are right now, we're on our x row. So, and we're going to fill in our w column. So right now we're trying to figure out our minimum cost to w. So first, what is the cost? So this is going to be the cost. So I'm in my W column. So this is my cost to W. What is my cost to W from each of these neighbors? So I'll look at their distance vector. So from W's distance vector, it costs 0 to get to W. From Y's distance vector, I see it costs 9 to get to W. From D's distance vector, D doesn't know, so that one's not going to be in there. And then plus, and this next one is how much does it cost to get from X, which is the node that we're on, to these. How much does it cost to get from X to each of these? Well, and now I can look at my distance vector from the column before. How much does it cost to get to X how much does it cost to get to X from W? It costs 10, but that one just makes sense. We already knew that one, really. How much does it cost to get to X from Y? Or how much does it cost to go from X to Y? How much does it cost to go from X to Y? It costs 4. How much does it cost to go from X to Z? It costs 8. So I add across. So 0 plus 10 is 10, 9 plus 4 is 13, and I can't add these, so that's nothing. So I take my minimum, and my minimum is 10. And so my minimum cost from X to W is 10. Now from X to X, that's going to be 0. Now from X to Y. So from X to Y, let's take a look at this. We can see that it currently costs us 4 to get to Y. Is there a less expensive way to get to Y? Is there a less expensive way to get to Y? Well, let's look at how much it costs to get to Y from the other nodes. To get to Y from W is 9. That's not less. To get to Y from Z is 3. That is less. Okay, so maybe we can use that one. But then we would have to know, well, how much does it cost to get, so we see that to get to Y from Z is 3. So 2Y from Z is 3. But I'm on node X, so now I need to see, well, how much does it cost to get to Z? So to get to Z from X, to get to Z from X was 8. So I'd add those together and I would get 11. So 11 is more than 4, so I'm going to see 4. I'm going to have 4. Okay, so we can still see this on our original graph. So I'm on my X column and I'm looking at the minimum cost to Y. Well, to go directly to Y is 4. To get to Y from Z would be 8 plus 3. And I know how to do that because I have received Z's distance vector. To get to Y through W would be 10 plus 9 is 19. That's obviously more than 4. Okay, now how about to get to Z? We currently have that it costs 8 to get to Z. Well, what if we went through Y? Can we go through Y? Well, do we have a distance vector for Y? We do, so we can go through Y. Okay, so how much would it cost to go through Y? Well, to get to Z from Y costs 3. So to get to Z from Y costs 3. But then how much does it cost us to get to Y? It costs us 4 to get to Y, plus 4. That's 7. Is 7 less than what it's currently costing? Yes, it is, so we'll put in 7. If that's the least one. It might be, we have to look at X's other neighbors. So let's look at W. How much does it cost to get to Z from W? To get to Z from W, well, we can't use that one because we don't know. How much does it cost? And I guess, is that it? Yes. So our choices were to go directly there, to go through Y. Yeah, because we can't go through W. So those were our only choices. Okay, so now we're on to our Y distance vector. So now we're trying to see what's our minimum cost to get to W. So to get to W, I can either go directly to W, which is my current cost, which is 9, or I could go to X first, which costs me 4, right there, costs me 4, and then to get from X to W, is 10, so that would be 4 plus 10 is 14. Well, that is not less than what I already have, which is 9. So what is my other choice? My other choice would be to go, so I can go directly there, I can go through X, I could go through Z. Well, to get to Z, it costs me 3. And then, what's my cost from Z to W? My cost from Z to W, I don't know it, so I can't use it. So that's not an option, so I'm just going to use 9. Okay, now I want the cost from Y to X. So from Y to X, I can go directly there, which is 4, so that's my first possibility. I can go through W. To get to W is 9, and to get from W to X is 10. That's right here. So 10 plus 9 is 19. That's not less. I could go through Z. So to get to Z costs 3. And then from Z to X is another 8 more. That would be 11. That is not less than what I already have, so I'll use that. Y to itself, of course, will be 0. And then Y to Z. And at this point, I know there's not going to be any lower cost. I'm not going to compute them all because it's just, I mean, obviously can't be anything less. There aren't any smaller numbers. It's got to be 3. Okay, and then finally, Z. Okay, so from Z to W, before we didn't know how to get there. Now we can look at X and Y and see how X and how much it costs from X and Y to get to W. So to get to W from X is 10, but to get from Z to X is 8. So this is 2W through X is 18. So now let's try 2W through Y. So 2W through Y. So from Y to W is 9. So from Y to W is 9, that's right here. But I have to get to Y in the first place. From Z to Y is 3, so 9 plus 3 is 12. And so my two choices are 18 and 12. So 12 is the smaller one, so I'll use that one. And then from Z to X is going to be 3. Like I said, there's not a smaller number. Oh, no, wait, that was not right. That was to Y. To Y is 3. Look at X. So our choices for going to X from Z, so I'm at node Z, so I can go directly there. I know that that one costs 8, so that's choice 1. I can go, I'm on node Z, so, and I'm going to X, so I could go through Y. So the cost from Y to X, is 4. That's right here. The cost from Y to X is 4. And then the cost to get to Y in the first place is 3. So that's 7. So plus 3 is 7. So that's to get to, let me write down what I'm doing here. So we are in our Z column. So we're looking at the cost to get from Z, so from Z to X. Now we can go directly there, and that would be our value that was in our original table, which is 8. And we can go through any of our direct neighbors. Now I'm at Z, so my only direct neighbor other than X is Y. I can't go through W because I'm not a direct neighbor. So through Y. So my cost to get to X through Y is the cost from Y to X, and the cost from Y to X is not necessarily going to be the cost that's in the original graph. It's going to be the cost from my table, because I might have found a cheaper way to get there before. So my cost to Y from X is 4. And then I need to get, well, what is my cost to get to Y in the first place? And that's 3. So that's 7. And 7 is less than to get directly there, which was 8. And am I doing the same thing I just did a minute ago? Yeah, I am. All right. And now from Z to Z, that's 0. Okay. So now let's go. We're done when none of the distance vectors change. If a distance vector did not change from the time before, then it doesn't send it to its neighbors. Did I not fill in W to Z? I did not. Okay, so let's go back to this top one. Did I do it and just not write it down? I don't know if I did. Okay, so from W to Z, we can't get directly there. To go through X is 18. To go through Y is 12. So it would be 12. Okay, now, did the X vector, did the W vector change? It did. It now has this 12 in it. That's not going to affect anything later on, but it did change, so it will send it to each of its direct neighbors. W's direct neighbors are X and Y. So it'll send its distance vector to X and Y. So 0, 10, 9, 12, 0, 10, 9, 12. Okay, did X's distance vector change? It did. The 8 changed to a 7. So it will send that to each of its neighbors, and its neighbors with everybody. So 10, 0, 4, 7. 10, 0, 4, 7. Don't fill it in for itself. 10, 0, 4, 7. And I did. That's exactly what I did, is I filled it in for itself, so I don't do that. 10, fill it in here. Okay, Y. Did Y's distance vector change? Nope, it didn't change. So it does not send it out. And again, you know you're done when nobody's distance vector changes. All right, and Z. Did Z's distance vector change? Yes, because it filled in this 12. It's not going to send it to W because it's not directly attached to W. Okay, so now for W, we know that 0 is going to stay 0. Now to get to X, so what we're going to look at is to get to X, how much does it cost to get to X from the other places? And then how much does it cost from W to get to X? Okay, so to go directly from W, what I just said doesn't make any sense, so forget that. To go directly from W to X is 10. The only other way we can get there is through Y. How much does it cost to get to X going through Y? Well, to get to X from Y is 4. To get to Y from W is 9. 9 plus 4 is 13. 13 is not less than 10, so we leave 10 in here. Okay, now we're going to look at y. To go directly to y, it looks like that costs 9. What about to go to y through x? Well, how much does it cost to get to y from x? It costs 4 to get to y from x. How much does it cost us to get to x? 10. 10 plus 4 is 14. That's not less than 9, so we leave 9. Okay, now to get to z. We can't go directly to z, so that's not even an option. What about to go through x? How much does it cost to get to z from x? It costs 7. How much did it cost us to get to z? It cost us 12 to get to z, so that's a total of 19. So that's not less than what we currently have. All right, what about to go through y? So how much does it cost to get to z from y? It costs 3. How much did it cost us to get to y? It cost us 9 to get to y. So the total is 9 plus 3, which is 12. So that stays the same. Okay, now for the x, and notice that distance vector did not change. Nope. Okay, now for x, we know the 0 is going to stay. 10. Is it cheaper to get to w than 10? Well, we know it's not going to be cheaper going through z. Could it be cheaper going through y? Well, how much does it cost to get to z through y? It costs 3. How much does it cost us to get to y? It costs 9. That's not cheaper than 10. So we can leave that. Except, was I doing the right one? I don't know what I just did. Redo that one. So we're going from x to w. From x to w. Our current cost is 10. What if we went through y? The cost from y to w is 9. Our cost to get to y is 4. 9 plus 4 is 13. That's not less than 10. What if we went through z? Well, that's not going to be less than 10 because the cost to w from z is 12, which is already more than 10. So that's going to stay 10. From x to y is currently 4. Is there any way we're going to get less than that? No. So we can leave that. From x to z, it's currently costing 7. Our only possibility here, let's see, so going through w is not going to help. That's 12. Going through y, it only costs 3 to get to z from y. I'm sorry, it only costs 3 over here to get to z from y. How much does it cost us to get to y? It costs 9. Okay, so that's not going to be less than 7. Did this vector change? It did not. All right. Y to w. Okay, not going to be less than 9 because if you just look, 10 and 12, it's not going to be less than that. Same here because we have 4, 7 and 10. That's not going to be less. Y to itself is 0. Y to z is 3. Again, we're not going to have anything less than that from our choices. And z. So from z to w, we currently have 12. So if we go through x, it would be 10. plus our cost to get to x, which is 7. That's 17, which is not less than 12. To go through y, it costs 9 from y to w, and it costs 3 to get to y, so that's 12, so that is the same. Okay, from z to x, it's currently costing 7. What if we went through y? Well, it costs 4 to go from y to x. How much does it cost us to get to y? It costs 3, so the total would be 7, which is what we already have. We're not going to get less than 3 or 0, and I think at this point, none of the distance vectors changed. So there was not a whole lot of change in this one. Since none of the distance vectors changed, we were done. And so if these, here we're done. If you look at the homework that we did for this year, there were more changes, so that will give you some more practice with that. And then I wanted to go back and talk about these. So what do these things mean? So iterative, we have steps, we do it, we try it once, and then we try it again, we see if we get something better, we try it again, we see if we get something better. And so iterative, just we're doing it, again and again until we get to a stopping point, and our stopping point is when none of the distance vectors change. Asynchronous, each node can act on its own. Nobody has to be doing this all at the same time. So it's asynchronous, they don't have to be doing it at the same time. And it's distributed because everybody's doing a little bit of the work. It's not centralized, it's not some central node that is sending out all of its information to everybody. Everybody is doing a little bit of the work. So those three things are things that I think are useful to know. So that's that. I'm sorry, I feel like that was kind of drawn out.